Who thinks instant response in the cloud is easier? Hands up. If you think it's easier compared to on-premise instant response. I think it is, but I'm the only one, I think. All right, that's good. Who think it's more difficult? That should be the rest then. Awesome. So who thinks the cloud is more secure by default than on-premise systems? One in the back, 2, 3, 4. Yeah, don't be shy. Yeah, that's good. All right. There's no good or bad here, you know. It's your opinion and you can always change it later. So this is a more interesting one maybe for the people that are doing a bit more incident response in the cloud. Raise your hands if you know what forensics artifacts you have available in the cloud. So if you're doing instant, do you know what's available? Yeah, all right, a few people do. Awesome. It can get a bit more complicated if you have multiple clouds, but that's sort of the start. So what we'll do today is we'll talk about cloud incident response. So talk a bit about myself, not too long, don't worry. And then we'll get into the more interesting details, of course. So what is the good, the bad, and the ugly of the cloud from an incident response perspective? So a bit about myself. So my name is Korstiaan Stam. I am, as you probably heard, not from England either. I am from the Netherlands, from a very small town, so I won't bother you with the details. I am an instructor for SANS, which is the training institute that you hopefully have heard of. I teach, no surprise, the Cloud Incident Response course. So that course is basically 6 days, and you go through all the different clouds from a forensics perspective. So we'll do Microsoft Azure, 365, AWS, Google Workspace, and Google Cloud. So those are the 5 topics basically. That's what I normally teach. So last week I had a fun time in Madrid where I was teaching this to a big group. Outside of that, I'm also, sounds very big, founder and CEO. But it's a small company, so I'm not a big shot, I think. But I have my own instant response company. And what I like to do with my instant response company is cloud incidents. That's really the sort of interesting place for me. I've done a lot of instant response over the year, and I think the cloud is unique and it offers a lot of opportunities that hopefully after this talk you'll agree with me that there's some stuff there that you might want to invest your time in. And also if you go back to your work tomorrow, next week, maybe you have some things you want to check on quickly, just to be a little bit better prepared. I also worked at PwC and Nordwave, which maybe some people know, maybe some people don't. I also like to develop some tools. I'm not a very good programmer, but I do try to build some tools, and they're all open source. I don't charge anything for it, but in the end, I'll have a little slide with all the links, and you can see some tools that we've built that will help you when you do instant response to make your life a little bit easier. So maybe some acquisition of data, maybe some analysis, all that kind of good stuff. I also used to teach at Amsterdam University for a bit, but no time for that anymore. But more importantly for today, who am I? I am a big fan of the cloud, and I'm a big fan of cloud instant response. So that's what I'm going to talk about to you today. Let's get into it. So for the background, you always have to, I think in a slide, some statistics, right, on why it's relevant that we talk about this. So this is my statistics slide that I shamelessly copied from the internet. So on the left-hand side, we have a little statistic that says, what are the biggest clouds? And no surprise, AWS, Azure, and Google Cloud are the most important one. We call them the big 3 of the cloud. So we are mainly discussing those 3 clouds. There are others. And I think that's the point that I want to make here. If you are in the instant response field or you have your own company, you might encounter other clouds. So it might be you're a customer of IBM or Salesforce, Oracle, especially maybe you're working in the China region or Asia region, you might have Tencent or Alibaba. There's even a few Russian ones, but I don't know how well that's going at the moment, but they are there. So I think the point here is the cloud is not just one thing. Every cloud platform is different. So if you are a company and you have 3 different clouds, you need to probably have some expertise on each one of them and also on how you can do your investigations there. Because there's going to be a time when you need that information, and ideally you would know something beforehand. Alrighty. So, cloud incidents, what do we normally see? So what are some of the things that I see in my real life, I guess, for my clients, that go wrong. So let's see how aware you are of this. So who can think of what a data breach in the cloud, what it would look like? Who has an example? It's going to be in all the newspapers normally. Winner, winner, S3 buckets. So everyone has probably heard about S3 buckets. It's Amazon's cloud storage solution. And it has been really hard for a lot of companies to protect them properly. So a lot of companies like Tesla and all the other ones, you don't have to name and shame them, but they've had a situation where some data was stolen through an S3 bucket. This is not just because it was open. It also happens, and that's more common I would say, through like number 6, more like the API attacks. So what happens is, if you work in the cloud, you don't just deal with usernames and passwords you have to protect or multi-factor. There's also something called access keys or API keys that you can give to a program or to a person that they can use it for their purposes. Those API keys, you put them in a nice little script, and what do? You put them on GitHub, yes, and then everyone else can enjoy whatever you've built in your own cloud. So we'll talk about a few incidents that I've worked on and where literally this happened 2 weeks ago. It's not fun, but it's pretty difficult for companies still to securely develop, I guess, or secure their credentials, whether it's username and password or API keys. So what are some of the other stuff? Very popular, I think it's going down quite a bit, is number 8, cryptojacking. So who has an idea what that means? In the back, sir. Scream. Awesome, yes, you are 100% correct. So it is, just repeating you here, it is when someone breaks into your organization, it can also be on-premise actually, but it's mostly in the cloud. They breach your compute resources or they spin up new computes, and then they try to use those resources to mine cryptocurrency. This used to be the big thing. It has gone down quite a bit because most of the major cloud providers have preventive measures to, I guess, prevent you from creating these machines or to mine for these cryptocurrencies. Also, you don't make a lot of money if you start mining for cryptocurrencies anymore. So the value is going down quite a bit. We won't go through the rest, but these are some of the, I guess, the top 9 incidents that have been there for a while. And the order might change next year, but it will probably still remain the same. This is taken from a Google report. So Google Cloud or Google in general releases quite a few good threat reports. This is a little bit old though, but it has some interesting statistics, I would say. So with an attack, normally you start with initial access, right? So from the bad guy perspective, you are trying to gain your initial access into an organization, into a cloud provider. What do we see after that happens? So basically, what does the attacker do after they got in? So in number 1, that's why it's a little bit old, it's cryptocurrency mining that you just discussed. What is more interesting, I think, and it's gone up quite a bit, is using your cloud environment to attack other companies that are also in the cloud or maybe they're on-premise. Why would we do that, or why would attackers do that? Well, a lot of security solutions, they inspect, for instance, incoming traffic, they do look at the IP addresses where it's coming from, the host names, and if you use AWS, or if you use Google, or you use a Microsoft IP address, it's less likely to be blocked on your parameter, but because who here dares to just block all Microsoft IP addresses from connecting to your environment? I think no one will ever do that. So that's pretty popular method. So using a cloud to attack another company basically. So I have an example of that I used to work on a nice incident where this happened. So we'll talk about it later. Let's dive into what are we going to talk about today. So the good, the bad, and the ugly. I mean, it's familiar for everyone, right? So what are the good things in the cloud? What are the bad things in the cloud? And what are the ugly things, so more from what has gone wrong in the past, where we can maybe learn from, hopefully. And also, I have basically what I try to do, of course, is whenever you're done here, I hope there's some things you can take away to your organization or to you clients that you can immediately check or do to be better prepared. and some resources. So I have some tools there that I use, and maybe it's useful for you as well. And hopefully, I mean, we'll definitely have time for questions after. All right. What are some of the good things in the cloud? What do you like if you're an incident responder in the cloud? You are going to like logging. So the big three, remember, Microsoft, AWS, and Google all have by default what we call platform logging, so the highest level, enabled and available for you. There's nothing you have to do to get this. You can improve this, you can increase the retention period, but by default, this is there. So let's say we look at Microsoft, we have something they use for their sign-ins, they use Azure Active Directory, which is a product. It contains all the details of who signed in, from where, with what method, did they use MFA, all the good stuff. It is available. AWS, if you forget everything about AWS, but if you remember one word, it's going to be CloudTrail. Indeed, that is the magic log that is there by default, and it's available for 90 days. You don't have to pay for it, it's going to be there. Google Cloud, they don't have a fancy name for their logging. It's just called Cloud Audit Logs, which is a bit boring in my opinion, but it does the job. The good news is here is look at the retention. So if you're a Google Cloud customer, yeah, it's pretty nice. Like you get 400 days of retention of your logging for free. So I think it's pretty good, right? We'll look at the bad with the logging, because it's not all good news, of course. What else do we like? So I call it premium logging. So whenever you're in a cloud, you will have your normal logging, right? So Azure sign-in events, you have your CloudTrail, but maybe you want something extra. So that's possible. That's what we call premium logging. So you have to pay for it. It's not free. Some of the most popular ones that I have used and that hopefully you get to use one day as well is NetFlow logging. So NetFlow logging is basically, it's metadata about a network connection. So it's source, destination, source port, destination port, protocol. Basically what system is trying to connect to another system. It doesn't contain the contents of the connection. But still, this is very useful. Who here has heard about Cobalt Strike, for instance? Cobalt Strike, yeah, it's an amazing tool, right? It's super legit, but it's also used by a lot of bad guys. Who I don't think they pay for a license either, but they use it for their incidents basically too, because it's pretty good. So the way it works is, Cobalt Strike is going to be installed on a system in your cloud, for instance. It is trying to connect back to its home system to say, yeah, it's all good, or do you have any new instructions for me to do something in this environment? That is what you call beaconing. If you enable NetFlow logging, you would be able to spot this. You would be able to see, oh, there's a system that is trying to connect every certain interval, or it's always going to this weird IP address. So that's what you can do with NetFlow logging. Unfortunately, and I'm going to be honest here, this is not on for the majority of the companies that I help. Why is that? It's pretty expensive, it's a lot of logging, and if you don't know what you're doing with it, why would you even enable it? So that's the thing you have to do as a company, is you need to make a little business case or use case out of it. So why do we want to have NetFlow logging? Well, for security reasons. Okay, well, what are you going to do with it? Well, we want to monitor for all the connections that are made outside of a set of IP addresses or to weird ports or weird protocols. That's NetFlow. Data access logging. And this has a different name in every cloud, so I won't bore you with the details. But the idea is, if you have data in your S3 buckets, in your RDS database service, wherever, you can enable in each cloud, mostly with just one little checkbox, data access logging. What does this contain? Basically, who accessed my data? This is super important, but it's rarely enabled as well, because it is going to be a lot of data again. If you run a web server and you have a database behind it and you have a popular product, it's going to be maybe millions of events each day. And what are you going to do with it, right? So then again, you need to think of, why do I want this? Or maybe what you should do is identify what are the really important data pieces in my environment that I want to protect and that I want to know when it's accessed, and then enable the logging on only those buckets or objects. That's also possible. But this is good. This is all available for you. And I mean, I have done some weird investigations. And I remember back in when we had like data centers, right, in the old days, when you wanted to grab network data, you had to go into the data center, you had to put in like a physical server and to have set up a span port to get all the network traffic. Here it's just 2 clicks and you have it available. So the ease of use is also pretty good. So what are some other things we like? The remediation and recovery. So every incident starts with what happened, of course. But at some point, the company wants to go back to normal, right? And they want to do so, hopefully, securely. So you need to do some remediation activity. So what's remediation? Is remediating whatever was happening. So we've identified what has happened. Now we want to kick them out. You have some good options available. So what I'll talk about a real life incident where I use this and it's pretty good in the cloud. So you can easily set up a separate organization, a separate tenant or a separate account and basically use that as a washing street. So you can say, listen, all these machines in my resource group or in my AWS account are compromised. I don't trust them anymore. Well, we can create a new one and just we're going to clean the old systems if we still want to use them. And then when it's clean, so we've gone through a little checklist, we're going to move them to our new AWS account or to our new resource group. Those are things that are really easy and straightforward in the cloud. Rotating credentials and keys. Well, if you have ever had a compromise of an access key, it is really easy to just say, I'm going to disable this key and I'm going to rotate it. So whoever had that key, if it was on GitHub, it's not useful anymore now. So it's not all good, of course. I'm going to be honest. I'm a big fan of the cloud, but there's also some bad stuff there from incident response perspective. So you might encounter some heavy weather behind the clouds. Centralized environment. So you know, if you want to set up your cloud environment, all you need is a credit card. Yes, you can just grab a credit card and you have your own little cloud. What is the problem? If you have an organization, you kind of want to have some sort of central governance, maybe some policies that apply everywhere. You don't have to. You can just grab your own credit card and make it and put your data there. That is by far the worst thing, I think. It's really difficult or really easy, I would say, for someone to spin up their own cloud, and it's really difficult to get everything back together. That's the bad part. Licensing. Well, if you have ever heard of Microsoft, they're probably going to release E7, E9, or whatever expensive license they're going to add. They love to add security options to their more advanced licenses. So if you have a license, the basic license, you can protect a little bit, you can use MFA. But if you want to disable MFA on one account and leave it on for the rest, that's not possible with the security defaults. So you need a next level license, which is a little bit more expensive. If you want to have a year worth of logging, you're going to need to pay a little bit more. That's my problem with the licensing from an incident response perspective. The security lag problem, this is a big one. I think this is the biggest one. Cloud providers, if you log into AWS, just try it, or Azure, you click on all services available. There's going to be hundreds of services that they have. And next week they'll have a new thing. Because they develop so much at such incredible speed and they put it out into the world to use. What is the problem? There's something called the security lag. There's going to be new features, new products, and afterwards comes security. So for instance, if you ever use Kubernetes, it's like a managed container thingy. Last week, AWS announced it's finally able to get you audit logging from whatever is running within your Kubernetes platform. It was not available up until now to inspect what was running inside your containers from a cloud perspective. I think that's a huge problem. And I guess what we can do about it, not so much, maybe complain to the sales department, but that's about it. Costs. If you've done incident response, if you have your own forensics lab, etc., you need to pay for the lab one time, maybe some expenses to keep it running. If you're doing incidents in the cloud, every investigation is going to cost you money. Why? Data transfers. That is the most annoying thing that costs money. So if you want to get data in the cloud, it's mostly free, right? You can get your data in the cloud. If you want to get it out of the cloud, it's going to cost you money. So if you make a snapshot of a machine and you're going to say, oh, I want to export it, you're going to be charged for it. That is not great. Multi-cloud approach. I see too many companies that have 3 different clouds, or maybe even more. They have Microsoft, they have Google, AWS, all of them. It is so hard to have knowledge in all 3 ones. That's the first problem. Next one is, do you also have knowledge about securing it? So maybe you have knowledge about running it. The next thing is, how can you secure it? So if you have so many different options available, you probably don't know what's going on, to be very honest. So that's a big problem. It's not necessarily a problem of the cloud, it's more a problem of the customers that use the cloud, that they don't. I don't say you have to get just one, but at least make a strategy. What do you want to do? Where do you want to standardize on, I guess. That's a big problem. All right, so I need to be wary of the time. The ugly. Let's go through some incidents. So I had a crypto mining incident. It cost the client $26,000 because all the machines were mining cryptocurrency. How much do you think it made the threat actor? Who wants to guess? How much money did they earn from the crypto mining thingy? You want to guess? 200 euros in this case. It was a Dutch client. So that's how little it works for the threat actor. But then again, they don't care. They just spin it up with an automated script and they have the little Monero mining pool running. So what do? We grab the logs and we use the resource group to basically wash and clean the systems. So a lot of the systems were not really touched. They were only used programmatically to spin them up, but not a lot going on, so we can reuse them if we wanted to. Last but not least, we work with Microsoft to show this was an attack. Why did the client want this? Otherwise they had to pay the whole bill. And now they could say, well, maybe it was an attack and you should have alerted us, and etc., etc. So that was an important piece of the investigation. What can you do for this specific attack? Set up your limits so that you don't just are able to spin up all the beefy machines in your environment for thousands of euros a day. You can set up limits, it's from a billing perspective, but you can also prevent that they can create these machines that are basically with a lot of GPU power and CPU power using policies. You can also do that. Next case, spear phishing through Google Workspace. So Google Workspace is, I love the topic, but not a lot of companies use it. But it's basically the business offering of Gmail. So you have Drive, Gmail for business, etc., etc. What you can do is inside Google Workspace, they have a nice little feature where they can say, I want to export all my whole address book. I want to export all the users and all the roles that they have whenever you're in. It is going to trigger an alert. So luckily for us, we were able to figure out that they did that. So why did they do that? Because they took the data and then started phishing another company or another customer that they actually wanted to target. So this is almost like a supply chain attack. So get into one company that is trusted by the actual one that you want to target, and then try to use that trust to get in. So what can you do? MFA. If you want to prevent your normal accounts from being taken over, MFA, and enable MFA everywhere. And there's also always going to be exceptions, but please, please try to enable it everywhere. And if you can, do the strong MFA option, so no texting, just use like, and if you really want to be advanced, maybe use hardware keys as well, so like UB keys, etc. But for most companies, that's a bridge too far, but at least try to, if you can. Case 3, this is the most recent one. Ransomware is going to the cloud. Yes, it is. So the problem is ransomware is a big problem, but it's also coming to the cloud. So we had an incident where the attacker came in. What they did was they were trying to see what access they got, and the only access they got was with 2 access keys to 2 separate buckets full of data, of course. They tried to create users, access denied. They tried to list users, access denied. Nothing worked, but they did have edit rights on the buckets. So what did they do? They disabled something called bucket versioning. What does that mean? That means that if you have a bucket, you can enable versioning and you can have old variants or old iterations of a file. So if they get removed, you can sort of recover. It's almost like a volume shadow copy in Windows. Pretty nice feature. They disabled it, which is very interesting for me because I haven't seen that in real life that much before. So it will be a nice blog somewhere later this year. And we did something very interesting, and this is a little trick that I hope you don't tell the bad guys. What you can do is if this client did not have data access logging on, so remember when I started, they could not say what data was accessed. They also couldn't really make a statement on if the data was exfiltrated. And that's what everyone wants to know, right? All the lawyers, your clients. So what can you do in AWS? This works in AWS and Google. You can go to billing, and there's a specific thing in billing that says, because remember, if you get data out of your cloud, it's going to cost you money. So there was an entrance there that said, this bucket, there was data movement from this bucket for a few gigabytes to another location outside of the cloud. It doesn't tell you where it goes, like not the IP address, or sometimes it tells you the region, but that's all the details you're going to get. The good news is, or not the good news is, we were able to confirm that actually data was exfiltrated as part of this attack. So we're able to say, this amount of gigabytes, does this line up with what's in the bucket? Yes or no? So then at some point you have to make an assumption, yes, they did actually exfiltrate my data, and I should notice my clients that this happened. So we're still actually monitoring this thingy. What we found was that the threat actor has like an automated script that just retries the access keys every time. So what we did was he disabled the access key for the compromised account, and then one guy in development enabled it for a little testing. Immediately we saw additional activity. So they basically have a script that's just running that retries to get into the environment. So be careful. What can you do? Don't use access keys if you don't need to, because they get exposed through GitHub things. In AWS you have something called IAM roles. You can assign a role to a resource instead of a person. So you could say, I want to have this machine be able, with this IAM role, to get data into this bucket. But that's all it can do. That authentication is within AWS. You cannot see those credentials going over the line. You cannot do anything with it from a threat actor perspective. This is the most secure option. Not a lot of companies use it. If you can, please do. Bucket versioning. Well, they disabled it. So how useful is this feature? Not a bit. I guess you could make an alert for it, and then you know something is wrong if someone disabled the versioning. You can also use MFA delete. What does this mean? If you want to delete data from a bucket, you have to have the MFA key. So in this example, if the threat actor had my password or my access key, he or she could not delete the data because they did not have the second factor. Very nice feature that they have. Use an immutable backup. So if you want to go one level further, you can use AWS backup, and then you're not even able with your accounts to delete the data. It will stay in there for a certain amount of time, and of course you're going to pay for the storage, but it will definitely prevent you from getting your data deleted accidentally or intentionally. Those were 3 cases, and I think I'm going over time, but I don't see anyone screaming, so I'll just continue. What can you do? Because I think maybe that's what people came here for. Prepare for incidents. How can you prepare? I'm going to go a little bit quicker. Update your playbooks. So if you have IR playbooks, make sure that they contain also information about how are you going to handle an incident in the cloud. So make sure you have a break glass account for the cloud that you can only use, or that you will only use for when you have an incident. Microsoft has some amazing free playbooks available on their website. You can copy paste them, and you can go to your management and be like, we have a playbook now. Yeah, it works like that. So you can do that. Maybe modify them a little bit with your own logos, but then you're good to go. Understand your artifacts. So we talked about what logging is available, right? Understand what is available, what do you have right now, and where are you storing it, and how long is it available for. So maybe you only have the cheapest Azure Active Directory license, you get 7 days of logging. Are you able to detect every incident in 7 days? I would say not every company is, to be honest. Otherwise I wouldn't have any work. But so know that part. Also, if you want, and if you can, and you have the budget, see what premium logging you want. So maybe you want the net flow for an important segment of your network. Maybe you want your data access logging for the super important bucket. Protect your crown jewels. So that's what the cloud actually offers you. If you have really important data in the cloud already, see what you can leverage that you normally couldn't do in the cloud. So there's something called just-in-time access, so you can protect your most privileged accounts their credentials by using just-in-time access. So whenever you need it, you'll get temporary credentials to do something, but only then. How does this help? Well, it prevents your account, that's very important account, from its password or credentials being exposed for too long. Invest in the advanced auditing options like E5. I know it's expensive, but if you can, please use it and your security people will be very happy, or maybe yourself. I'm not getting paid by any of these cloud providers to say this, by the way. I'm not getting any money from this. So this is a very cool one. Simulate an incident. So AWS has released 5 workshops where you can run your own incidents in a test environment. And they give you like malicious scripts where they encrypt your data, they delete your data. And then afterwards, you're going to search the audit logs to see if you can understand what has happened. So this is how you train your team, yourself, to what is going on. Like, it's really good and it's all free. So check it out. IR workshops, if you Google it, or I can send you the link, you're going to be happy. Stratus or whatever else there is, there's a few open source products that let you test detection. So they let you run a fake attack, and then you can see in your logging or in your alerting where you're able to detect it if it happened for real. So Stratus is one option. I think that's a free one. There might be more. So everything you prepared, but it still went wrong, right? It happens, I think, a lot. So what the most critical part is of incident response in the cloud is investigate and understand the extent of the breach. Here's where most companies and also incident responders go wrong. Do you really know what happened and the full story? So if they got your access key, you can go to your CloudTrail and AWS and see, oh, they did this and this and this. But maybe they also created a new user. Now you have to go to the new user and see what did that user do and what did those access keys belonging to that user do. Make sure you understand the extent. If you don't, you're going to be like us last week where we say, oh, or maybe you have a developer that just enables the access keys again. Then you're going to be in for a fun time because the incident will come back again. They don't forget about your keys. Don't take any shortcuts here. Just take your, I know it's stressful in instance and everyone wants to go back to normal, but you need to properly investigate. Leverage the cloud capabilities. We talked about this. So if you can, use isolation in the cloud. So you build a little new VPC in AWS and Google, or a new segment in Microsoft to just move your clean resources there or contain the instance. You can easily say, this resource group in Microsoft, I don't want it communicating to the internet anymore because I think it's compromised. It is so easy to do that, way easier than the old days where you had to go to someone in networking, have someone in switch and change something. Use it to your advantage. Use premium logging, we talked about it. What I like is you got storage options for days. If you want to create snapshots of all your machines in every region, you can do it. It's going to cost you money, but it's possible. You'll never run out of storage. Automation. So let's say you already did everything that I talked to you about. Next step is automation. So try to see, can I, from an alert in Sentinel, in guard duty, in whatever security center from Google, can I automatically then create a snapshot of that machine and extract the logging? That will be your next steps in the cloud. Alrighty. Resources. This is mostly self-promotion, I'm not going to lie. But these are all tools on the left-hand side that we've built from our GitHub that will help you with incident response. These all are used to acquire data. So if you want to acquire data from Microsoft, grab the top one. If you want to do something in AWS, grab the next one. And if you want to do something in Google, we come up with a pretentious name of Alpha, and you can use that one. Yeah, come up here, make a picture. That's fine. I think it will be somewhere recorded as well. On the right-hand side, I built a little Splunk app as well, so you can automatically analyze your data. And last but not least, if you are not lucky enough to have a Splunk license or a Sentinel license and you want to try it for free a bit, you can use Elastic. And there's a special distribution of Elastic. It's called SofElk. That will be there to help you analyze your logging. So you can basically grab the logging out of the cloud, put it in SofElk. The next slide is questions and answers. So I'm just going to leave this here for everyone who wants to make a picture. And sorry that we are a little bit late, but are there any questions for me? at this moment in time. Yeah, go ahead. I'll repeat it. So the question is, what about collaborations with the DFIR teams of the cloud? This is possible. So all of them have their own IR teams. I mean, Google, Bolt, Mandiant. So you can, for a price, you can just engage them. Yeah, you can hire an external party basically. So whoever you have, or you can call us or whoever to help you. That's how it works. Any other questions? Well, then I guess last but not least, I want to thank you so much for your time, and it was great having you. I hope you have a great day.